Hi, everybody. This is Mark Schuyler. I'm glad you're with me today. We're going to go over some more mental math. This is a follow-up video to my first mental math video. Hopefully you saw that. Then comes what might be the most famous mental math problem in history. Let's take a look at it right away. It's intriguing to say the least. What is the sum of the first 100 positive integers? And what really makes this intriguing is you can't use your calculator and you're not allowed to use pencil and paper either. You just have to find some way using your mind, mental math power, of adding all the integers from 1 to 100 in your head. Quite the challenge. I've had a few people look at me and say, impossible. And you know, you're right. I think even Einstein wouldn't be able to sit and quickly add all the numbers from 1 to 100 in his head. But Einstein might be able to figure out the cool little mental math trick that'll allow you to do this. Of course, there's a pattern. There is a shortcut. So to be able to see that, let me start off by writing some of the first integers down for you right here. I'm not going to write them all out. That would take forever and you'd get bored and you'd go elsewhere. So instead, I'm going to use some ellipses, the dot, 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 to kind of show you what the numbers are that are between 3 and 98. But we know we want to add all this stream of numbers from 1 to 100 together and get one large sum. So what you do, and it's very easy to see visually, is add together 1, the smallest number of all, to 100, the largest number. And what do you get? I'll write it here. You get 101. But what you might not have thought of is that you get 101 also when you add the second smallest number to the second largest number. And you're going to get 101 again when you add the third smallest to the third largest. And you're going to keep pairing off these numbers and always getting a sum of 101. If you have 100 numbers to begin with, how many pairs will you be able to create? Well, when this problem was first explained to me years ago, I was basically told, imagine 100 people on a dance floor. If the instructor says, everybody pair off, you're going to have 50 pairs of 100 people. So let me write that down. In our problem, we're going to have 50 pairs of 101. And please remember that of in math problems always means perform multiplication. Of means multiply. So all we really have to do to finish solving this problem is mentally multiply 50 times 101 in our heads. Now, some students believe that this is beyond them, that this is too difficult, but I disagree. We want to change the problem just a little bit. Instead of thinking of it as 50 times 101, think of it as 50 times 100. And you know that if you multiply any number by 100, you just add 2 zeros to that number. So 2 zeros added to 50, let's do that here. If we were doing 50 times 100, that would be 5,000. We have the initial 0 with the 50, the 2 zeros coming from the 100, that's 5,000. But if you go back and look at what we were originally dealing with, we were originally dealing with 50 times 101. So we actually have one more 50, not 100 50s, but one more 50, 101. So we're going to have to take our answer, 5,000, and add that extra 50 to it, and we get the final solution to the most famous mental math problem in history. Final answer is 5,050. There we go. Almost makes it seem easy. Well, let's try it again, only this time I want you to do it all by yourself. What's the sum of the first 20 positive integers? I'm going to let you work on that as I just write out. Work on it in your head, of course. Don't use pencil and paper. I'm just going to write out a few things here while you do this mentally. Believe it or not, I think that should have been enough time. If you remember to pair off the smallest number with the largest number, you're going to get 21. And you'll always get 21 when you pair off the second smallest to the second largest, another 21. So we have how many pairs if we have 20 numbers? If we take 20 numbers and pair them off, it'll be 10 pairs of 21, which is just multiplying 10 times 21 because of means multiply. And I'm pretty sure that everybody can multiply by 10. You just slap a 0 onto the back of whatever number you're multiplying 10 by. So we're going to get 210. Boom. And it should have been seconds that we can add all those numbers together. But a lot of people would pick up a calculator and they would start typing in. And sometimes they even get the wrong answer. Really, I've seen this. I've challenged a student, go ahead and do it with your calculator. I've timed it. It takes quite a bit of time, minutes, to type it all in, or at least a minute if you're really fast. But then, because you're fast, you type in just one digit incorrectly. Maybe you typed in 13 plus 15 instead of 13 plus 14, and your sum is wrong at the end, especially in our first problem where it said add all the numbers from 1 to 100. Here's another challenge one for you. What's the sum of the first 10 positive integers? I'll give you 5 or 6 seconds. That should be enough time. All you do is you pair them off. I'm just going to do 1 plus 10, that's 11. I know I have 10 numbers, so that's 5 pairs. 5 times 11, 55, done. And where this applies on the SAT, you might be wondering, you might be thinking, hey, Mark, this is a really cool math trick, but how might this be tested on the SAT or the ACT in the world of standardized tests? Well, they often test it in something called the handshake problem. And I've given you what I think is a pretty typical example. 45 people in a room are told to introduce themselves to everyone else in the room. How many separate introductions will occur? How many will there be? So I'll let you think about that. How would we answer this? And recall, you're not going to shake your own hand, right? That makes no sense. We're not going to introduce ourselves to ourselves. So when I go around the room, I'm imagining I'm one of the 45 people. I'm going to go around and I'm going to be involved in 44 separate introductions. But then I'm done. I should almost stand in the corner at this point and let the next person go around the room and introduce himself or herself to everyone else in the room. And that would be 43 introductions. The person's not going to count the introduction they already had with me. So that would be introducing themselves twice, right, to the same person. So it's going to go down from 44 to 43. But then that person is done. And the next person should go around and introduce himself or herself to everyone. And that would be 42 introductions. And that person can stand down. And you see where this is going. We're going to get down eventually, there's my ellipses, we're going to get down to a place where there are just a few final introductions. And then the final 2 people introduce themselves. One final introduction. What does it all add up to? So really, we do have the problem. What's the sum of all the numbers from 1 to 44? And once again, I've sometimes heard complaints. That's too hard to do in my head. But it's really not. We know that when we add these up, we're always going to have 45 when we pair off the numbers. Every time it's going to pair off to 45. Well, how many pairs of 45 will there be? Well, we started with 44 numbers, 1 through 44, so that would be 22 pairs. So 45 times 22, it may seem hard, but even in your head, think of it as mental math power. Just, I've heard of someone called a math magician, but really, they just break things down into simple steps. Here's one. Instead of multiplying 45 times 22, we could think about multiplying 45 times 20, and I know that 45 times 20 is really 45 times 10 twice. So 45 times 10 is ridiculously simple. I'll write it down. Add the extra 0 is 450. But we know there's another 10 in 20, so 45 times 10 again is another 450. If I add those 450s together, it's going to add up to 900. But that would just be 10 and 10, 20 of the 22. We've got 2 more 45s that we have to add on to our sum. Well, 2 times 45 is 90, so 900 plus that final 90 gives us a final answer of 990 is the answer to our handshake problem with 45 people in the room. So these are pretty amazing math problems that can be done. Go astound your friends, go amaze your family, but most of all, you'll find places where you can use these on the test instead of grinding through the problem with your calculator and maybe even punching in information incorrectly on your calculator. It can be faster to add up these numbers, these consecutive numbers in your head. So thank you for watching, and I'll see you on the next video.